Hello, ChatGPT.
Hello. Hi again.
So, here I am to start my very first YouTube tutorial video. It's all about DSA, system design,
Mm-hmm.
AI. Okay, so first I will start with the DSA problem. I will start with a very basic problem.
Okay.
I want you to behave like an interviewer to me. So, I'll be solving a question. You will see how I'm doing, and you can ask some follow up questions.
Sounds good. I'll play interviewer. Go ahead whenever you're ready.
So I have opened this question on LeetCode. It's a two sum.
Mm-hmm.
So given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. Second constraint is you may assume that each input would have exactly one solution and you may not use the same element twice.
Okay. So walk me through your thinking. What's your brute force idea first?
Yeah, so first I'll be solving by brute force. So I'll be using two loops. In both loops, I will be traversing the whole element. And when indices I and j are not equal, at that moment I will be comparing some of their values is equal to target or not. If it is equal to target, I will simply return I and j.
Mm-hmm. Good. So what's the time complexity of that approach?
Let me solve it and then you can do the follow up, okay?
Sure.
So I have nums, which is a list of integers, and I will take the length. So n underscore length equal to len of nums, and for I in range and length, as I said, I will run two loops for j in range and length. If I is not j, if nums of I plus nums of j equal to target, and simply return I and j. Let me run this if it is working or not. Okay, there are three test cases to test and it is working fine. So I'm submitting it and I'm assuming it should fail with, oh, it is accepted. So I was expecting time limit exceeded, but it doesn't. Maybe because it's a easy problem and they're not bothering about the time complexity. But here is, I'm sending you the screenshot or whatever I did, and then you can ask me follow-up questions.
Sure. Sounds good. Send the screenshot. So if I were the interviewer, I'd say your solution is accepted, but the runtime is 4,175 milliseconds, slower than 95%. Why use is not for comparison?
Can you come again?
Sure. Instead of if I is not J, use if I not equal to J. Is
Okay.
not checks identity, not
Why?
value.
Yeah,
Checking.
okay.
Great question. So is not checks if two variables point to the exact same object,
But
which isn't
I and j is a primitive
right.
data type, right?
Yeah. For
So it should compare the
primitive
value instead
numbers.
of reference.
Yeah, exactly. For numbers, prefer value comparison like I not J. Is and is not check memory identity, and that can behave unexpectedly here. Try not for indices.
Okay, I removed it and I make it like I is not equal to j, means using call operator.
Yeah,
This is
use
what you mean, right?
not for the indices. Exactly. Yeah.
Okay.
Is for identity, but not compares values, which is what you want here.
You are right, but that happened only in case of objects, right? But here I and j are just a primitive type. Maybe if I'm misunderstanding because I am from Java background. There, when we see reference comparison, that I understand that happen in case of non-primitive data type. But here, when I am comparing I and j, I'm assuming they are comparing. Sorry, when I'm doing I is not j, I'm assuming it is comparing their value. Correct me if I'm wrong.
Checking. In Java, your instinct makes sense, but Python doesn't have primitives the same way Java does. In Python, is checks if two variables point to the same object, while not checks value.
I replaced is not with the not equal operator, getting almost same response. I'm sending you the screenshot again and you can check it.
Checking that now. Yeah, I checked. That result looks expected, but that change doesn't improve the time complexity. It's still O of n squared.
Correct.
So the runtime won't change much. If I were interviewing you, I'd say, nice fix on the operator. Now, can you improve the brute force itself? For example, try iterating j from I plus 1 to n to avoid duplicate checks.
Okay, yeah, you are right. Here in this case, I am starting second loop from the very beginning, which is wrong. Because for those elements which is coming before I have already checked it. So it's a duplicate check, I guess. That's what you mean, right?
Exactly.
Yeah, okay.
Start j from I plus 1.
Plus one, correct.
That
You're
skips rechecking pairs.
In
Yeah.
that case, I can remove one if condition where I'm checking I and j are equal or not, and let me submit it and see if I improved or not. Oh yeah, I improved.
Good improvement. I see the runtime drop from about 4181 ms to 1477 ms.
Yes.
That's solid.
Yeah.
You can explain you noticed duplicate pair checks and started j from I plus 1 to cut redundant comparisons.
You are right.
Next, if I were interviewing you, I'd say good optimization. Now, can you reduce the time complexity to O of n? Which data structure would you choose and why?
Okay.
Walk
so
me through your thinking first.
Yes. Okay. So here in this case, I was running two loop, and so the complexity was like big of n square. So I can solve this using map. I will take a map which is blank initially. I will traverse the whole element again in nums. When I get an element, I will do target minus current element, and whatever I get, I will see if that element exists in the map or not. If it exists, then I will simply return. Okay, so in map, I will be storing the value as a key and indexes as a value. So
Checking.
so that
Good.
if I get number target minus current element exists in map or not. If it doesn't exist, I will simply get that index for that particular number, and I will take the current index and I will return both.
Yeah, good direction. I'd encourage you to say, I'll compute the complement and check the hash map.
So I'm taking one hash map num index. It is blank for initially. I will remove one loop and okay. What you said, complement, right? But why you are saying that complement? Because it's not complement, right? It's a target minus current value.
Checking.
Which element you are exactly saying complement element?
That's the standard term. Yeah. For each element, compute its complement as target minus nums I and check if that complement exists in the hash map.
Okay. This is standard term.
Yeah.
Okay, I got
That's
it.
how most interviewers phrase it. Yeah.
Got it.
So you can say, I'll compute the complement and check the hash map.
Okay, so I'm running through the loop, and for every element, I'll calculate the complement. Target minus nums of I. If complement in num index, then simply I will return num index of complement, comma current index. If it is not, I will do num index nums I equal to I. Okay, let me run it. Oh, I did some mistake. Let me see. Num is not defined. Okay, I added instead of nums, I did num. Okay, let me submit it. I'm getting 0 millisecond. I'm sending you a screenshot.
Okay, sure. Looking. As your interviewer, I'd say this is the expected solution. You compute the complement, check the hash map, and if it exists, return the pair of indices. Otherwise, insert the current value after checking. Now, if I were in the interview, I would ask you, why do you insert after checking instead of before? And what's the time and space complexity?
Okay, can you
Also,
okay, you have a lot of questions, I guess. So can you come
Yeah.
one by one? Sorry, my
Sure.
bad. Yeah.
No problem. First question, why do you insert the current element into the hash map after checking for the complement instead of before?
Okay, so okay, if I do it before checking the complement inside the num index or not, so what I will do?
Checking.
Yeah, let's
Take
see.
your time.
Yeah, yeah.
If I were the interviewer, I'd let you reason it out. A good way to
Okay.
think about it is if nums equals 3, 3, and target is 6, what
I got
happens
it. I
if
got
you.
it. I got it. So if let's say as you told me, if the input is 3 3 and target is 6, and if I
Yeah.
check this before if condition, my hash map will already having 3. Okay, and I'm checking again for the 3, which is 6 minus 3, which is complement, and again I'm checking if the 3 exists or not, and 3 already exists in the num index. That's mean I'll be returning the same indexes like 0 0.
Checking. Exactly. If I were interviewing, I'd say, good catch. You avoid matching the same element with itself. Now, next, I'd ask, what's the time and space complexity of your hash map solution?
Okay, here like I removed one for loop. So currently I'm using just one for loop. So time complexity is big of n, but I introduce one hash map. So space complexity become big of n.
That's right. O of n time and O of n space.
Yes.
Now, that's a clear, solid explanation.
Okay. Are we good, or do you have any other follow-up questions?
Just one small note. Instead of saying I'll be returning the same indexes like 0, 0, in an interview, say something more like I'd incorrectly match the current element with itself, which violates the problem constraint.
Yes.
Other than
yes.
that,
You're right. You're
nice
correct.
progression.
You're right.
Start with. Exactly. You started brute force, removed redundant checks, then reached the optimal hash map approach. That's exactly what interviewers like to see.
Okay. So are we good for this video?
Yeah,
Okay.
we're good.
Thank you, ChatGPT. We will come again with another problem.
Sounds good. I'll be here.
Thank you.